Knack.
Dr. Bilo.
THOWL. Actually, my old university.
Your old university. My old university as well.
Of course, yeah.
That's where we met.
That's where we met, actually.
Yes. Alma mater.
Talking about meeting. Who do we meet today?
Uta Potgieser, colleague in Detmold, colleague in Delft, partner in the facade network, and we're going to talk about stick systems. It's a very special type of stick systems. It's a timber main structure stick system, and I like it a lot.
That was actually my very first wooden stick system.
The details we always use. Come. Uta, post and beam facades. We need to talk about the layout, how they're organized, and what functions do they fulfill.
Okay, Oli. So post and beam system. What is the characteristics? The post and beam system can also be called a stick system because we have the separate elements of the vertical posts and the horizontal beams, which are separated sticks that are stick together to build a facade. And normally they are put together on site. They are prefabricated as elements, but then mounted on site. And the layout of these facades can be, of course, individually designed, and it might depend on the function that is inside. So do we have offices, and we have a typical grid that is applied of 1.25 m or 1.50 m or something like that between the vertical posts. They can also be put together much closer if, for example, for design reasons that might be needed. And what is the function? As all kind of facades, it is first of all the separation between inside and outside, and as such it fulfills a thermal function. So to create a certain U value, a thermal separation, it's a kind of weather protection of the inside from the outside. And of course at the same time the post-stick system offers a lot of possibility to put huge glazings inside, which means we also provide the inside with very good daylight conditions. On the other hand, we have to protect it also from overheating and too much sun.
Right. Typical materials we need to talk about. Main structure of this stick system, the infills, we see glass and others, connection to the building, and tolerances.
So, main structure is, as we pointed out in the layout, there is the separation between vertical elements that are normally put in between the ceiling and the floor, which are the posts, and which we can also observe if we look inside the building. The main structure, the posts, normally have a certain depth because they have to deal with the wind loads, and they have to perform in the right way with not too much movement at the same time. And this defines, so the height actually of the floor normally defines also the depth of the posts. And that might also depend on the material, of course. And in this case, we have an interesting case of a wooden and aluminium construction. So outside the aluminium for weather protection, and inside we have a wooden framework. There might be differences if we look at the posts or at the beams. So normally the beams take, the posts take most of the loads, and the beams might be a kind of infill. So they might be smaller. Here in our case, they have the same depth, and they build a kind of frame. And we already also mentioned the material. The most typical material for these constructions nowadays is still aluminium, although we have to say originally it was steel that where the facades came from. But since, let's say, the 1950s, so post-World War II architecture, aluminium took over to be the main material for these kinds of facades. And since it has proven to be a good weather protection and also a lightweight material, of course, and it has good anti-corrosion, let's say, it's not corroding so fast compared to steel.
Material of the infill.
What type of infill?
Yes, the material of the infill. Very obvious. Normally it is glass. And here, of course, this is already, and you may see it, it has a kind of color on it.
Can I go for different infills? Can I go for alternative materials like what we see here?
Yeah, yeah. So normally we don't want to have a 100% glass facade, at least not nowadays when we talk about climate change and energy transition. So we know that a complete glass fill provides good indoor daylight conditions, but at the same time we also have a lot of overheating issues, or at the same time we may also have heat losses. So that means that normally we combine the glazing with opaque fillings that could be the parapet elements, and in our case it might be interesting that also the window opening in itself is not a glazed opening, but so the fixed elements here are the glazed elements, and the openings are the opaque, the non-transparent parts of the facade.
And how's the building connected? How's the facade connected to the building?
Well, that's not visible, unfortunately, here, not really. But we have certain specific elements that carry the beams there, so that allow also for tolerances and for adjustment of the facades. But maybe we have an expert who can help us explaining how the connection to the building is made in particular. And I would like to ask Marcel.
Dr. Bilo.
Oh, okay.
Dr. Bilo.
Dr. Bilo can give some insight.
In general, we have a mounting system that is connected to the concrete floor that allows for certain movements. So in principle we have, in this case, a standing facade post that is fixed to the floor, and it's held in position on the top via a movable bracket.
So okay, this is the stick.
It is able to allow.
Okay.
In principle, you have to move. I'm the building in right now, and this will be actually to move. In the construction site, you can see actually slotted holes that allow for this movement. It's for the elongation of the beams during the different seasons for the materials.
Bottom part, the concrete is here, and then it just stands on top.
No, in this case, it is in front of it. So we have within the section, you would see that the facade is mounted in front of it, in order to get a good clean junction to the floor and later to the flooring system on top. Okay. And the facade runs in front of the load-bearing concrete structure. Hope that answers it.
That was a very detailed insight. You have built it, right?
Yeah, I was actually with Tim Klein and of course Beate, the architect. We've done this at the student project. We built actually our own university. It was 3.5 years of my life, sort of. It was kind of busy. I made my diploma with that building. Quite a thing.
Quite a thing. Do you think we are able to peel off this?
No, you shouldn't. You shouldn't. Please don't.
I shouldn't.
Please don't. Please don't. We will have later a facade system in a detail.
Okay, if I'm not allowed to peel off, I continue with the text. Openings. Uta, we need windows. We need to get somehow ventilation done. How does that work?
How does that work? So here in our case, we have a quite traditional way of opening. So we have, let's say, quite huge opening sashes, a window. Yes, that is an opening that has about, 1 meter by 1.50 meters, so kind of huge window. And we have, in this case, we also have some overhead.
Oh, the flaps.
Some overhead flaps or louvers, or how you want to call it. So that's maybe an interesting aspect at this building, that we have a combination of different openings. So the big ones are done to let in the sun, to make a kind of cross ventilation during the day, something like this. And the upper ones, the louvers, are particular openings that allow for night cooling. What is a night cooling? So this is a building with a lot of glass still, and also here there might be a risk of overheating, although we have a sun protection to the relevant sites. So during the night we can open these louvers on the top, and they will bring in the cool night air. And by cooling down also the massive storage, which is the concrete ceiling here, it will hopefully reduce the temperature overnight by 1 or 2 degrees.
I have to ask a question, does it work?
Well, I think it works. I think it works.
The engineer's there. You think it works? Okay.
Well, I mean, it's maybe 1 or 2 degrees. This is what normally calculations say. So the question is, how is it perceived by the people? And how much impact do the number of people have that are in the building? So there is a lot of variables, and maybe the perception of the sun coming in and having a lot of people in the building is more dominant than the 1 or 2 degrees that might the building be cooled down overnight.
And you also said that there's a shading system. Where can we see the shading system? This
Well,
is north.
This is the north
So it's not
facade,
relevant for
so we
shading,
cannot see it, although the detail is
there.
a similar one. But if we just have a look around the corner,
Yeah.
which is the western facade, we can see that the louver system is integrated into the building and automatically.
I see Dr. Bilo coming in.
Now, yeah, we have to some sort of come to an end. Sun shading is already the next chapter we would like to highlight on a different video. Do we actually?
Yes, we do.
We have a sun shading chapter, but of course it's nice to mention because it's so close here. We can also have a little view from the south side where the facade is actually fully shaded. But I think for the topics we have covered it all. Thank you very much.
Should we repeat it?
No, it's good.